Assalamualaikum and a very good day. So for today's chapter, we are going to learn about the array. So this is going to be two different videos, because we are going to concentrate one for the one-dimensional array, and the second one will be a two-dimensional array. So in this video, we are going to learn about the one-dimensional array. So we are going to look at what is the definition of array first. Right, so what is array? Array is a data structure that contains group of elements, usually of the same size and data types. Okay, so in an array, it should have the same size and same data type, normally like that. So there is another term that they call for the one-dimensional array, which is, they call it a list. Okay, a list is a one-dimensional array, whereas matrix is a two-dimensional array. So you are going to learn both one-dimensional array, and the second one is a two-dimensional array. Okay, so we are going to concentrate first on the first one, is the one-dimensional array, like this. So an array, you can create an array by using the command that we've been using before, which is the define constant. So ds, which is a defined storage, I'm not going to talk guys about this one. So we are going to concentrate on how to use the define constant .by or .w or .long to create your own array over here. Okay, so for the case of the two-dimensional array, so you just look at the difference on how we what you call it, write the command here. Basically it's quite the same, but there will be a bit different in terms of the declarations of the define constant .by. So this is going to be the list, and this is going to be the matrix. All right, so how to understand, how to create and understand what is actually you're doing in an array. So in an array, right, you can create the names of the array. For example, here in this case, you can create a name cards array or suits array. So these will be the names, it's up to you. Okay, and in this case, the define constant .byte for the cards is all 0. The data is all 0, but it's actually same size, which is byte. And also the suits, also here the example is the same one, right? So there are 5 elements, okay, inside here, 5 elements in the array. Okay, so cards and suits are 5 byte, because this is define constant .byte. It's one-dimensional because it's only one line over here, right? There will be no 2 or 3 more lines. So here you can see that it's actually one-dimensional array. So each array represents one row of 5 values. So this is one row and 5 values, which is 5 elements lah. Alright, so this is 1, 2, 3, 4, 5 elements. Alright, but now when you look at the index, which is the specific element access, depends on the position in the array. So if you want to change any value in the array, you must know what will be the index for each of the elements. Okay, the index will be used to access, which is to read and to write the array in the program. Alright, in this case, right, you have to understand what is the definitions of the index, right? So for the case of this one, okay, so here you have 5 elements, right? So like this, 5 elements, but the index is the range of 0 to 4, because it starts from 0. So the range of the index will be based on from 0 to 4. So for this case of the cards, right, so you have to understand that the first one, this one will be the index 0, element number 1. Same goes to the next one, index 1, element number 2, index number 2, element number 3, and so on up to the last one in the array. So for the case of this one, it has a 0 to 4 range only, so you need to know that which one is which one for the index. Elements is different, index will be different. Okay, how to write or how to read. Okay, how to read and write. I mean, right now you need to know how you can create an array, and once in the program that you want to read or you want to write the array, so you have to understand how to write the syntax. Okay, in this case, right, for the array, you have to know how to use the operand notation like this, which is the first one. This is an, which will be the address, and this is going to be the index. So the an is actually the base address. Base address is where, okay, for example, you put the array in the memory. Okay, for example, right now you want to create a memory, an array in the memory. You can use your ZZCCAK, right? So right now you can try to put here. Okay, this is your program, and remember that you can clear, you can create your array somewhere else by define again the origin when you want to put, for example, is origin 2000. Okay, so next will be where you want to this is where you want to put your array. That now will be the elements in the array. So define constant dot byte. Because of this, we are going to try this one first. So hash, okay, 1 2 $, 3 4 and 5. So now you are actually declaring or creating an array at location 2000. So let's run this one first. Okay, so let's look at the results here for the memory at 2000. You already have the elements inside the array. This is 5 elements, and the index is starting from 0 here, 1 2 3 4, and the base address here in this case, right? So this is a base address, can be any address. Base address will be at the 2000 location. This is the base of the array, so the address is at 2000. So means that if you want to access any of the array, one-dimensional array, you need to know that where is the base of the elements, where is the base of the address for the first elements, and later you can find the index. Then you can touch any of the elements inside the array based on the index. For example, this is index 0, index 1 2 3 4. Alright, so this is the case. So right now, for example, you want to read. Okay, here is the example here. You want to read, okay, the value from the array, one of the elements. So in this case, right, in this example, we want to read the elements at index number 3. This is the index. Okay, so because you can see here, the first command is after you declare or you create your own array, right? Inside your program here, this is move address.long. This is the command to take what is the address for the cuts here. Cuts is the labeling for this array, so we want to find out what's the address for it, so you can put it at A0, because A0 later can be used over here. So in this case example, we are going to put our array at area 2000. So now when this command is executed, right, 2000 will be going to be used at and stored at A0. Alright, next one is the move.byte number 3 to D0, because this is going to be a pair at the end, A0 D0. So the first one might be going to be a 2000 here, and the second one is going to be third index, and this is going to be sent to D1. So in this case, right, the index will be 0 here, 1 2, and this is going to be sent to D1. Read. Okay, let's try. Okay, let's try this one. I'm going to open up this one again. Okay, This is the same command just now, right? So I have the cuts elements over here, and then I have the command here to move the address of the array here, because this cut is labeled to this one, and then move to A0, because that will be the address you need to access first before you get the index. So in this case, it's move.by index go to D0. Alright, so move.by A0 will be the address for that one, D0 will be the index, and going to be sent to D1. Means that the value index number 3 will be copied and sent to D1. Means that you are reading the value in the array. So let's try to look at the example here. Okay, so the first one is to move the elements, the address of the cuts array, which is something start from here 2000, because you know that you have put the array values from the beginning of 2000 locations. So 2000 will be insert to A0. So let's look at the results. A0 right now is 2000, correct? Right now we are going to move 3 to D0. D0 now got number 3. Now this command is move.by, you have the bracket, right? A0 is already contained at 2000, and then D0 contain 3. So means that you want to touch the array, you want to read the array at a location 2000 with the index of 3. So index of 3, so you have to look at the what you call that again, the memory here. The index number 3 is going to be 0, 1, 2, 3. You are expecting this one to be out to send to your D1. So let's look at the results here. D1, yeah, D1 now is written with 0, 4. So you can try to play around this one. Not at 3, you can try maybe 1, right? So you execute this one again, and then you can try to do it one by one. This is going to read 2001. 2001 is this one, right? 2, sorry, not 0. This is index number 1, should be 2. So this is the results. Correct. So right now you can read from the array by using this pattern of command. You have the bracket, you have the address, and you have the index. Okay, now how to write. Just now you just read that one, right? So right now is how to write. Write is different case. Okay, but nearly the same. You still need to use this one, but we are going to look at the write process. Alright, the write process, sorry, let me check this one. Oh, this is still not updated. So let's try to look at the process here. So the write process might be different like this one. Okay, looks at the write process here. Okay, the write process is a bit different, just a bit different, where you are going to change the sequence, I mean the locations of the command here. Instead of this is at the first beginning just now, right? For example, just now you can see here is this one, right? A0 to 0 to D1 means you are reading from and then send to this one. But in this case, you are going to write the value inside the array. So when you look at this command, right, the first one is to define the array, which is the normal one, and then you have your process here. All right, the first one you are going to look at the address for the array here, cuts send to A0, and then you are going to look at the index. This is, for example, you want to look at the index 1, okay, element number 2. Okay, this is index 1, go to D0. So you have the value here 2001. So this is going to be the value replaced inside the array. Okay, so let's look at the results from the command here. Right, so now here you are going to get the address for the array here. This is hash cuts. Cuts is the label for the array here. This command is move address for the cuts to A0. So 2000 will be saved at 20. Here's 20. So next one is move.by 1 to D0. So D0 will get 1 here, right? And now right now the last command is to move.by value here this is A0 2000, D0 is 1, so you are going to replace a value inside the memory. So let's look at the memory first at 2000. This is the original value 1 2 3 4 5 based on your results here, based on the syntax over here. So right now I'm going to send or write this value to at 2000 element number 1. Element number 1 we are expecting over here 02. Okay, so we are expecting AA to be replaced. Sorry, AA will be replaced this value here. So let's run this one. Yeah, you can see the value right now had been replaced for the elements number 2, index number 1. So this is how to write. You can see the difference is only based on the locations of the syntax operand notation. This is to write, and the previous one is here, which is to read. Okay, so the next one will be this is just an example, right? This is just example where you can read and you can write. This is a combination of the software of the code syntax. You can try and look at what will be the results, but you have to understand which one is which one basically. So this is the things that I already segregate out, where here you can see the read process, or you also can see the write process. Okay, and the last one for this chapter is about how to calculate the effective address of any elements in byte, word or long word. Effective address, what is this effective address? Okay, let's look at the command here just now. So the effective address for the array here, or for example, index 0 is 2000, index 2 is 2001, this is next one is going to be 2002, so etc. up to 2004. So this will be what you call that, this will be your effective address for each of the elements. Okay, so you know that by looking at this one, this is very simple, because if you have a very small array, you can just calculate by yourself, right? So by using formula, right? Okay, formula to get any of the elements effective address, you need to know what will be the base address. Base address is starting of the address for the array, and then you need to know what's the index element. Okay, for example, you know that the element index before, then you can know that what it will be the effective address. So size will be what? Size will be based on the size that we are going to use, byte, word or long word, and the offset is about the, this is actually the offsets are size times index is actually what is the offset into the array to elements position. This will be the offset. So the formula is quite simple, right? This is the one. EA effective address is equivalent to the base address plus the offset. So how many offset that it has? It will base on the size and the index of the array itself. So for example, that when you declare the array as byte, right? So you need to have this one, and you need to know what would be the index here. So for example, here in this case, right? In this case, this is index number 1, 2, 3, 4, 5. All right, this is number 1, 2, 3, 4, 5. So this is going to be index 0, 1, 2, 2, right? So index is 2 times byte here, right? So this is 2. So base is 2000 plus 2. So that particular position, this one is equivalent to 2002. Is it correct? So this is 2001, sorry, 2000, 2001. Yeah, this is exactly the same one. So this is how you can calculate the effective address of the elements inside the array. Okay, so that will be the first video for the array, which is the least, which is one-dimensional array.